Hi folks, I'm just recording this because I've had a few questions from students that indicate that people are having a little bit of a tough time putting all the ideas together that show up in Chapter 6. So I'm going to try to summarize the big takeaways that you need from Chapter 6. So the first thing that I have on this page, I apologize for my messy handwriting, but I'm kind of doing this on an as-needed basis, is that you have to understand the difference between an expression and an equation, because when you see it, whether it's an expression or an equation tells you what you're supposed to do with it and what your answer is going to look like. So expressions are things like this over here. And what we typically do in Chapter 6 with expressions is we factor them. And with expressions, you just change the way they look. You don't figure out what x is equal to. You just rewrite it in a different way. So, for example, this one, if I were to factor it, I could write it as x times x minus 7 because that has a greatest common factor. This one is a trinomial, so I could use the product and sum information to say, okay, this one is, let's see, x plus 3 times x plus 2, because 3 and 2 multiply to 6 and add to 5. And this one is 2x minus 7 times 2x plus 7. That's a difference of 2 squares. So what I've done here with these expressions is I've rewritten them. Instead of having a subtraction problem, I have a multiplication problem. Instead of having a bunch of things that are added or subtracted, I have multiplication here. But I'm not telling you what x equals, because I was given an expression to begin with. And an expression is something that basically doesn't have an equal sign with something on the other side. On the other hand, this side over here, these are equations. And you know that they're equations because they have this equal sign here and there's something on both sides. And so this is something, if I see one of these, I know that I'm being asked to solve for them, which means tell me what value of x I plug in to each side in order to make the left side equal the right side. Same thing here. This has an equal sign with something on both sides, so what I'm asked to do is solve it, meaning x equals a number is what my final answer should look like, or maybe x equals two different numbers. And similarly here. Now, in Chapter 6, the whole reason that you're taught how to factor is that factoring is the technique that we use to solve these. So to solve equations that have exponents bigger than 1, we use factoring and the zero product property. So for example, I'll just pick one of these. You know, if I wanted to solve this middle one right here, solve x squared plus 5x equals negative 6, I'm going to use factoring to solve it, but I need to make it equal to 0 beforehand, because the zero product property, I mean, it's called that because you need a 0. So I'm going to bring this 6 to the other side. X squared plus 5x plus 6 equals 0. Now I'm going to use the techniques that I learned over here with expressions to do something with this. I need to factor it so that I have a multiplication problem. This factors into x plus 3 times x plus 2 equals 0. And then that means that each of those factors could be 0. So my solutions are negative 3 or negative 2. Now, I didn't know exactly what the numbers were, but I knew way at the beginning, way up here, what my answer was going to look like. That my answer was going to look like x equals a number, or x equals one number or another number, because what I was given was an equation. Whereas over here, if I'm just given something like this, and I'm not given an equal sign with something on the other side, I'm not being told to figure out what x is. I'm just being told to change the way it looks. And the way we change the way it looks is to factor it. So they're closely tied together because to solve the equation you need the factors, but you need to know what your final answer is going to look like. Okay, so there's the difference between an expression and what your answer looks like, and an equation and what your answer looks like. And the other thing that I want to make sure you understand is the connection between when you're given an equation, how you solve it by hand, and how you solve it with a graph. I hope you got that by reading the examples in the book, but just in case you didn't, I'm going to go through a couple of examples here. Okay, so let me take a problem like this. So solve x squared minus 6x equals 7. Okay, so the first thing that you need to recognize is that this is an equation. And so since it's an equation, my final answer is going to be x equals a number, or maybe two numbers, or maybe three numbers, depending on what the equation is. But you're actually figuring out what x equals. Because this has an exponent other than 1, we've got an x squared, sometimes you have an x cubed, you need to use the zero product property. And the great thing about the zero product property is it tells you what you're supposed to do in order. So it's called the zero product property, and the first step you do is you make it equal to 0. So I'm going to take this 7 and move it to the other side. The second step is I write it as a product, and when I write it as a product, that means I factor it. So if I factor this one, it's going to be, let's see, a product of -7 and a sum of -6. I think it's going to be x minus 7 times x plus 1. And then I use the property that says if when I multiply two things I get 0, one of these original factors had to be 0. So this is where the property says I can split this into two separate equations. X minus 7 equals 0, or plus 1 equals 0. So I get two solutions, x equals 7 or x equals -1. Typically you would write that, -1 comma 7. So I have two solutions. That's how you do it by hand. Now you should know that every time you have an equation that you're solving by hand, you can solve it with a graph as well to check your answers. So what I'm going to do is I'm going to bring up my graphing calculator, and I'm going to remind you how to check your answers with a graph. Here's my graphing calculator. Let me kind of slide this over here to the right. So if I want to use my graphing calculator, oops, I made it disappear. I'm going to look at this line right here where this is equal to 0. And that's what I'm going to use for my graph. Okay, so if I want to solve this with a graph, I'm going to take this equation that's equal to 0 and I'm going to put it into y equals. So I'm going to put x squared minus 6x minus 7 in here. And the 0 actually, that's where the y is, the thing that x squared minus 6x minus 7 is on my calculator, that's where the y is. So I'm looking at places where y equals 0. So let me press graph and show you what that graph looks like. And you'll notice that the points where y equals 0 on a graph are the x-intercepts. And so if you look right here, that's an x value of -1. That matches one of my solutions that I got by hand over here. And then if I count over here, 1, 2, 3, 4, 5, 6, 7, that x-intercept there is at x equals 7. That matches my other solution. So anytime you do anything by hand using the zero product property, or really using any equation, you can always check it on a graph. So let me do this one. 2x cubed minus 12x squared equals negative 18x. Okay, and the directions for this would be solve. And the reason the directions would be solve is that this is an equal sign here with something on both sides, so that tells me that I'm trying to get numeric answers for this. What value of x could I plug in for x to make the left side equal the right side? So anytime I have an equation that's got exponents, like x cubed and x squared, again, I want to use the zero product property. Sometimes I call it the ZPP. So the first step is the zero part, which means I need to make it equal to 0. So this is 2x cubed minus 12x squared plus 18x equals 0. And then the product part means I need to factor it. And so I need to look at all the strategies that I've had in Chapter 6 to figure out how to factor this. This is a trinomial, but it's also got an x in everything. So the first step of factoring is always to factor out a greatest common factor. So in this particular case, I think there's a 2x that's present in all of these terms. So I'm going to factor that out, and that's going to leave me with x squared minus 6x plus 9. And then I need to look at what's left and see if I can factor that. So I still have this factor of 2x out in front. And then this is a trinomial. I'm looking for two numbers that give me a product of 9 and a sum of negative 6. And I think that's minus 3 and minus 3, or negative 3 and negative 3. So you may have recognized this as a perfect square trinomial. The other way to write this is 2x times x minus 3 quantity squared equals 0. So that's your perfect square trinomial. Any way you get to this x minus 3 squared is okay. So we did the 0 part. The factoring was the product part. Now I need to use the property that says that if I have one or two or three things multiplied together that give me 0, then one of them has to be 0. So I'm going to end up with either 2x equals 0 or x minus 3 equals 0. So this one is going to give me a solution of 0. This one's going to give me a solution of 3. Sometimes people ask, do I need to write this one down? Well, it's going to give you the same solution, so since it's not giving you anything new, you don't have to write it down again. So I have two solutions, 0 and 3. Then I want to remind you that anytime you have an equation, you can check it with a graph. So here's the line that says equals 0. That's the one that I'm going to put in to my calculator with a y1 where the 0 is. So let me bring up the calculator. I'm going to go in here to y equals 0 and clear that out. Now I'm going to put in this equation, 2x raised to the third power minus 12x squared plus 18x. I got the 2x cubed. Yes. Okay, so now I'm going to press graph. And this time I don't really get a U shape. I get more of a squiggle, and that's because of the x cubed. But again, if I look right here where it crosses the x-axis, and the reason I'm looking for where it crosses the x-axis is that that's where that y equals 0. So if I look right here, this crosses the x-axis at x equals 0. That matches one of my solutions, and if I count over 1, 2, 3, that touches the x-axis there at my other solution. So these solutions right here match the x-intercepts, and that's the way you can always check for your solutions.